right? And so I've given you 4 questions before you actually started this section. We asked you to come up with graphing or determining what the nature of those roots would look like. Specifically, let's look at the question y equals x squared minus 6x plus 9. Y equals x squared minus 6x plus 9. So if we were to graph that, and I'm not going to do it the long method, I'm actually going to do it the short method by just typing it in a graphing calculator or graphical calculator, and then you get to tell me what it looks like. So I want you to look at this thing over here. Now remember what I said a root is. A root is essentially the x-intercept. Now if we zoom in and we look at this curve and we look at this graph, as you can see it's a parabola. Now you need to tell me, where does this graph touch the x-axis? Where does it touch the x-axis? Okay, so it touches the x-axis at this point over here, at 3. Do you see that? It touches the x-axis at 3. The other question is, does it touch the x-axis anywhere else? If it only touches the x-axis at that point, then we can say that it only has one x-intercept, that this curve has one. Okay, let me just use red because red is convenient. We can say that this curve has one x-intercept. And if it has one x-intercept, we also say that it has one root. It also has one root. Okay, at that point over there, it only has one root. Okay, so let's look at another curve, and let's take this one away. Okay, so let's look at the second curve that you were supposed to look at the nature of its roots. If we look at it, x squared minus 4x plus 3, if I were to graph that curve, it looks like this. And now can you tell me, where are the roots of this curve? X squared minus 4x plus 3, where are the roots? Well, you can simply tell me that the roots occur at 1, that's the first root, and the other root occurs at 3. So what can you tell me about this curve? This curve has got, or has, 2 roots, right? It's got 2 roots. And what else can you tell me about the 2 roots? These 2 roots, they are different. So R1 has a different value to R2, if you can see that over there. Okay, so there are 2 roots for this curve. Okay, so we clear? If we graph this one, we've got 2 roots, root 1 and root 2. Okay, the first x-intercept, roots times 2, or you can say that there are 2 x-intercepts for this curve. Right, so let's look at another one. Let's look at the other one. Let's look at curve number 3, and you can tell me what's going on over there. Curve number 3, I'm going to switch that off, and let's graph this curve. This curve looks like this, x squared minus 4x minus 3. And if you look at that, you can tell me that there's a root and there's a root. In the other one, both roots were positive. In this case, there's one positive root and one negative root. And we want to look at exactly what that means for us. Okay, so let's highlight the roots. The first root is over there, just before -1. The other root is just before 5. And if I look at that, I'm going to call this R1, and I'm going to call this R2. And I'm going to say that this curve also has 2 roots, or 2 x-intercepts. Okay. And now let's look at the last one. Let's look at the last one. Let's graph that curve and take this curve away. Now if you look at this curve, can you see where the x-axis occurs? The x-axis occurs here at the bottom, right? This line over here that we see here. But this curve lies above the x-axis. In fact, we don't see anything about where this curve cuts the x-axis. So when we look at this curve, we say that this curve, I'm not going to highlight any roots now because this curve has no real roots. In other words, no roots that fall on the Cartesian plane here, mapping the real numbers to the real numbers, because there are no real roots. Okay, so now I want to take the investigation further, and I just wanted to give you an introduction to seeing that some curves has only one root. For example, this curve over here. This curve over here had 2 roots, both were positive. In other words, both x-intercepts occurred on the positive side of the x-axis. And this one over here had one negative root, one positive root, and the final curve here below had absolutely no real roots. So you can really see that when we talk about the nature of roots, we want to actually see whether those roots are going to be real. In other words, can you find a number? And when you graph it, does it touch the x-axis? And then when you do graph it for curves that does or do touch the x-axis, you actually want to see whether they touch the x-axis once. That's when we say they only have one or equal roots. And if they touch twice, then we say that the roots are distinct or unequal. Okay, so I'm going to take this investigation a little bit further after this, and we're going to summarize our findings in a table.